Okay, why don't we get started? Well, welcome everyone to this talk that Tammy's giving us on her research in cost optimization and requirement management for space systems. I have started the recording, so when you're ready, Tammy, thanks again for giving this, and I'm excited to hear hear about your work.
Thank you very much. I appreciate the opportunity to share this with you. So as an introduction, my name is Tami Katz. I work at Ball Aerospace, and I have been in the aerospace industry for about 30 years. I am currently a PhD student at CSU, and I'm finishing up. In fact, my dissertation that I'm highlighting here for you today is actually scheduled for the final examination in a couple of weeks. One of the reasons I wanted to share this content with you is because I took a lot of MBSC courses, particularly the one at CSU, as well as a few others. And I recognize that there's tons of methodologies on developing a system model for various purposes, whether you are trying to do a simulation for a trade study, or whether you're trying to just assess how things could work when you execute them. So this particular project that I worked on, I'm going to put a few slides together here to show you the whole point of what I was doing. Why was I modeling? What problem am I solving? And then I'm actually going to go, I have the model up, and I'm going to walk through it with you and run a few cases with you. And hoping there's time, I'll be happy to make this a little more free form and allow questions and dive into things with you as well. So I'm going to get started here. Turn this page. All right, so I'm going to tell you the problem statement. What was I solving? And then I'm going to talk about the process models I developed. And then I'll talk to you about how I engaged in doing this SysML modeling technique in a way to help me understand how the processes interact with each other and how they can be compared against each other. So as I said, I work in the aerospace industry, and I have, through experience, recognized that developing a space system can be rather complex. It's a complex system of systems. And developing a complex system overall requires a lot of additional system engineering, I guess, process control. But when you're dealing with space products, you're often dealing with a lot of custom, one-of-a-kind solutions. And you really need to understand your customer needs for those quite crisply and decompose those to a series of requirements. And often space systems requirements can run in the thousands, tens of thousands, actually. And so you really want to make sure you have a robust methodology of developing and managing those requirements, or you could inadvertently impact a project's cost or schedule or its ability to meet the technical objectives. So my dissertation investigation focus was to see if there were processes we could apply to ensure a requirements-driven engineering effort can be implemented to meet the needs of the project and all the constraints, such as budget and schedule. Is there a cost-effective way to manage a program's requirements? And why would we want to do that? Well, you know, just a couple of screenshots here on some challenges in recent history, but you'll tend to find that requirements problems show up in many different ways, including the inability to meet the whole need of the product. I mean, it just doesn't work. Or subtly, such as you don't meet your schedule and you don't meet your costs because maybe you uncover things late in the test program. Ultimately, you may find problems in validation. What you designed does not really meet the ultimate need of what the customer wanted. So, you know, some examples of common requirement problems are here, but I wanted to research complex space systems, understand what has gone wrong in the past, and show that requirements management, when done poorly, could impact the project, but when done well, you know, there's lots of techniques to enable the project. Okay, so this is my research. I'm not going to go too in depth on this, but I will say that I did a lot of literature research. I did interviews, and I found a current state process model. And as you see, I drew it here in Visio. And the idea is there's lots of different steps in the process. You don't necessarily need to see all the individual boxes, just know they all stand for some series of process steps that need to occur. And in each of those steps then are various activities that occur. So there's multiple depth that you go through. I definitely focused on the idea of managing a set of data. There's a whole bunch of process models related to just developing requirements on their own. The requirements development itself, it has been well researched and well modeled in terms of process models and literature. But what I found was missing was this idea of what do you do once you have your requirements? How do you control them? How do you manage their updates? And what good approaches could be introduced to ensure that you have a very cost-effective methodology. So in terms of some of the things that I researched as challenges and current trends, one of the things I highlighted was your requirement quantity as well as quality can greatly impact your project cost. This is actually well documented. There is a movement away from a document-centric approach towards a data-centric approach of managing a project's requirements and minimizing what you call modular or document-focused efforts into a comprehensive project data. That is actually reflective of an MBSC approach overall today, where people are integrating a lot of the project data from various models or various artifacts together to get a holistic look at how their project is performing. And requirements are very much like that. So in the top here in this figure, you see most people are familiar with requirements being part of a specification, which in their mind is a document. Whereas the newer trends are putting them as more of a holistic tool, perhaps a database of some sort. And even some of the common databases we've had, like DOORS, which is a common program, still looks at things more of a document or modular focus, where more the newer tools do more of a whole project focus, where you can just kind of organize your data a certain way. So that's becoming a newer trend. And then also these requirement management tools that are more current are more user-friendly. And we're finding that when you have more user-friendly tools, you have a lot more people in there looking at the data, reviewing the data, and helping assess any impacts of change or quality of the requirements. When you have a very difficult to use requirement management tool, which you'll find is most system engineers are the only ones that interface with it. And sometimes you'll end up with a system engineer on the project. That's their only job, is to interface with the tool. And so the last thing I've observed is change control. When you actually start baselining requirements and managing the data versus when you're still kind of figuring out what your requirements look like. When you lock in, that baseline matters. So these were the themes I took away. So I decided to investigate them into 4 unique areas of process control. I came up with a hypothesis that these 4 individual processes would all find benefit if enacted, but each one on their own would provide some benefit. So if somebody wanted to investigate in using a new tool or using a new approach, maybe they could start with one of these processes, but ultimately the goal is all 4 of these show some merit. And in that diagram I showed you earlier, this is kind of the green areas of where those would fit in. So to take this to the next step, then I have to figure out, well, how do I show this? How do I show what these various areas are? Implementing a data-focused requirements management approach, utilizing a management tool to support electronic collaboration during the development and change activities, minimizing and consolidating the requirements. That's another one that deals with requirement quality and quantity, and coordinate the timing between your development effort and levying your requirements officially. So I ended up making process models of each one of these, and I looked at the current state and I looked at the proposed optimized approach of my hypothesis. So in this, you'll notice the current state are always colored yellow. I kind of use that as a way to say, warning, this may not be the best approach. And all my proposed ones are shown green, which is, I'm thinking this is a better approach. Now I used Visio. So my previous diagram and these diagrams are all drawn in Visio. And as you can see, I predict, well, what are these steps and how can I measure what is going into each of these steps? What is involved? Typically, I'll use labor hours or duration of somebody's time to do something. Sometimes we'll use SysML, which is a cost modeling tool using requirement quantity and quality as a contributing factor. And then sometimes I would think of direct costs. When you deal with subcontracts or a supplier, you'll often have some direct costs associated with changing requirements when you have a contract already in place. So those are my 3 measures. So each of these 4 processes are drawing out something like this. This is the first one. And I'm going to deep dive into this first one with you here as I show you my modeling effort. So of course I have to figure out what are those labor hours? How do I figure out what goes into that? So I spent some time looking at typical tasks and using a lot of my own experience or observations from other subject experts. I did a range of durations for each of these. So instead of saying it's exactly 40 hours all the time, I figure it could probably be somewhere between a week to 4 weeks or a week to 2 weeks of effort. And then I would then put that range of times for each of these boxes. So on this table, each of those are reflected to what would the range of this effort typically be, and why would I think that? Additionally to the labor hours, I then utilized the idea of the SysML model, which is an Excel file, and the change cost optimization model, which I came up with in Excel that I'll show you here in a minute. So if you've not heard of this, SysML has a lot of history associated with it. And I know that I have it in the reference of these slides. I also think you can Google it and find it pretty quickly. But what we have here is an Excel file where a project, a space project, this is built specifically for projects like spacecraft, could enter in their estimated or their number of system level requirements. And then you see the parameters of easy, nominal, and difficult. Now I just went with nominal and difficult here as a measurement of quality. And when you read the drivers associated with them, difficult is a lot of overlaps in the requirements, not very traceable to the needs. And nominal is fairly traceable and fairly consolidated. So those are the 2 parameters of quality I focused on. And then quantity had to do with how many numbers you're putting in there. Are you dealing with 5 requirements or are you dealing with 500? And so where I really utilized this then was some initial predictions of comparative costs between projects based on number of requirements. But then ultimately I wanted to be able to use this to compare various process options. If I were to consolidate and improve my requirement quality, what could that look like if I did it by 10%? As an example. So this is one methodology aside from the labor hours that I used for a measurement point. Another is direct costs. So I came up and I did this first order optimization model, and I did this in Excel. I was originally planning on using an optimization program in MATLAB to calculate this, but it turns out I didn't need anything that elaborate. Excel did the job. So I took a linear line of, if I knew I had a very immature set of requirements, it would probably take some level of months to mature them to a much more stable state. And then if I knew that I had schedule impacts, if I was late with my product, and that would compound as soon as I was late, I was able to find the best point to maybe levy my requirements where I'm not late and I'm not incurring a lot of penalty fees, but I'm waiting a little bit to mature them. So what would that look like? And so I developed this little Excel file just to kind of predict that based by a series of parameters such as how stable are my requirements, how long does it take to make that product, and when would that product be needed, when must I start. I also figured out a project may know its estimated change cost with a supplier. They could all change, but they'll either have some suppliers that will charge very much for changes and some that will charge a lot. And then also if that product's late, what's the impact to the project? What would the penalty cost be? So these are all approximations that we could have as entry points for a project to kind of figure out that optimal point. So these were all inputs. But then I figured I need a way to run all this together. I need a way to understand how these different processes can interplay. And Visio wasn't really going to do the job, right? Visio is a good way to communicate the processes. And Excel probably could do the math for me, but it won't show me all my various trades, options, process interactions, decision points. And so I really needed to run a simulation. And when I was thinking about what would work for simulation, I was taking the MBSE course at the time. I thought, why not utilize SysML as a method to get simulation to prove my hypotheses, to show the different processes compared to one another and how they interact, and just see how the data could flow from that to either confirm or show perhaps I wasn't quite on the right path for my hypothesis. And so we do have a Cameo Systems Modeler through CSU. So I, managed to secure a license for this research and decided to take that path. So the first thing I did after taking a class on how to do this was to generate a requirements management model. Now I'm going to show you screenshots, but I am also planning, once this is over, I walk you through the highlights. I'm going to actually open the model. I've got it open and I'll run through some of it with you. So we did use the Cameo Systems Modeler. I am using the Cameo Simulation Toolkit plugin. I'm also using a plugin for Excel. There's an Excel import. And as you can see, I have 2 Excel files I'm going to want to use. So I'll show you how I integrate those into the model. I also have 4 process themes that I want to model. And I called them, process 1, 2, 3, 4, just like my hypotheses. And I have a current state and a proposed optimized. So I'm essentially doing a comparison of options against those. I did manage the requirements process as a block diagram. And then I managed also to put all the data elements associated with that as value properties. I originally created more model than I needed as I was figuring out how to model. So a lot of the things that are shown here, I ended up not using, but it helped me understand a little context. What I really ended up using a lot was this block here and all these value properties that I'll expand upon shortly. But a lot of them are either inputs or assumptions for the measured data. I did do activity diagrams where I looked at the individual processes as activities, and I did a holistic requirements management superset activity diagram where I put in a path of selection for whether I want to take an optimized route or the current state route. The overall requirements management model, I then simulated it using some actual data parameters from past NASA programs. And go on to the next slide. Some of the resources I used as I was generating this, I'll highlight now because this is actually really what I needed to develop this model. And I thought instead of waiting to the end, I'll show this part to you now, and then I'll go in and dive it a little more into my model. But the key is the Cameo Simulation Toolkit does have an online manual. And so I completely picked that apart. It has some sample problems in there, and I walked through simulating activity diagrams and understanding duration constraints. Those are 2 areas that were really important for me in that. The MBSE Execution YouTube channel was a huge resource for me. And I did manage to find some samples in there that were relevant to what I wanted to try. And I walked through those samples first before I tried doing my model, just so I can teach myself a fundamental set of skills. If I got those to work, I can then expand them to what I was trying to model here. There is a Excel video in that YouTube channel that I utilized heavily, and that was how to integrate Excel into SysML. And I think I have a link there for you. And then I also, they have sample models that come with Cameo when you go in there. And I know that Dr. Herbert goes over those in his class. And those I actually dove through too and picked those apart to try and figure out how did they model and how did they get to work. So I made an overall requirements management process block, and then I made blocks of my different proposed processes and current state processes, again, using the yellow and green color coding to keep myself aware that I was dealing with one versus the other. It helped me actually a lot. And you can adjust the color of your blocks just by going into symbol. So that was one of the first things I learned to do. And then I made them associations. One of the errors I had was understanding generalization and inheritance and how these things can connect. And so having these as associations actually worked better when I was running my simulation. So I defined all the value properties once, and then these blocks inherited those properties. The construction of my model is shown here, but I'm going to open it up shortly so you'll see more depth of how I organized it. I did originally make a requirement associated with a project schedule, thinking I would utilize that in my simulation, but turns out I did not need that. And that's probably an area we can go into future work and compare it to a requirement, but I ended up not using the requirement. I organized a structure, and I had essentially all of my blocks for my various, I would say, activities. And then I built behaviors and activity diagrams that were the main behavior for those blocks. And this is an example of one. For the process model on a document-centric approach, which is a current state approach. And I have all, my backup has every one of these models in it, but I'll focus on this one. I took my activity diagram from Visio, and I built my activity diagram in SysML to reflect the steps. And then I added the extra things like here I say number of documents, labor hours times number of documents. Well, I need then to have a loop that has it run through that when I have more than one document. So I figured out how to do a loop counter, which was another thing I had to learn. You'll see here I have my counter increase, and that is an opaque action. And so I go in with a set of count equals 1 and document count is assigned as shown here in this instance. So I used instance blocks to assign my parameters. And time is initially 0. And then as it goes through and calculates these duration constraints, I'll show you, you can either have it do the minimum set or the maximum. So we'll either get all the minimums or all the maximums, or you can have it do a random or an average. But it'll go through here until you have the dot count equal to the counter, the count equal to the dot count, sorry. And then it'll go through and capture the time and record that time for us, and then reset the counter. So that's what I learned to eventually do. And the first time I was able to actually get this to run through and do all this correctly was when I started to actually start to see results. So it took me a little bit to get to that point. So I learned how to make the value property dot count. I learned how to assign it. I learned how to do the opaque actions, and I learned how to do the duration constraints. And that's all how I managed to ultimately get the simulation to show data for me. Now, to do a simulation with Cameo Simulation Toolkit, you need to create a simulation config. And so I did make a config and I set the parameters. You can have it run real time, but as you saw, I was using 40-hour duration, so I couldn't have the simulation take that long. So you can speed up to faster than real time by setting a clock ratio, such as this. And this is what I got from the some of the samples that I saw on running activity simulations. You can have a simulation mode of minimum where it takes all the minimum constraint times. You can change that to maximum. It'll take all the maximum constraint times. Your other options, like I said, are random or average. So then you can also tell it where to put results. So I set a folder for that. And I said where to grab the inputs from. And that was that instance block I showed you earlier. So once you set all these parameters, you can also choose to use a timeline chart. And my timeline chart here was essentially set to represent that block. And when I show the sample, I'll show you one where I did one with a timeline chart and one without, so you can kind of see comparative difference. But essentially will show you all the chunks of time as it works through the simulation. This is a visual. We'll run it through here shortly, but you essentially see your simulation config up in this menu at the top. And I have a whole menu of them now because I made a lot. And you can press the play button and it'll go through and take all the inputs from the instance and start running through. And you could see the highlights as it runs through. And it'll put the values here in the lower end, and it'll walk through your simulation clock. Now, one of the things that was a challenge for me as I was running this the very first time was I didn't realize to put start time to 0. And so what it is it has a running clock. So if you don't set start time to 0, when it starts your simulation, it just picks up wherever you're at on your PC clock and just kind of runs through. So you have to kind of normalize that start time and tell it what units you want it to measure in and what steps. So that's what I've got here. I've got it in hours, step size of 1 whole hour. So it'll run through for me. And once you do that, I got repeatable results with my time. That's what I was having challenges with, getting that to repeat every time with the same entry parameters. So when you do run through this, you will see it will give you a kind of an exported number. It says this took, so many hours to run. And so then you can go and create your other process and have it run. And then you can change parameters like doc count, and then you can run it again. And then by doing this, you start to slowly build up a data set. Here's an example of the timeline chart when it runs. And here's an example of the data set I was able to build up. As I turned a knob, such as doc count here, I was able to see the hours of completed time change and vary. And this is the plot of minimums. So I ran everything at the minimum durations, got all that information, and then I ran everything at the maximum durations. And that results in a range in this. So I exported all this to Excel, and then I did a graph. And so here are all the minimum times in this yellow line, and you saw my yellow and green theme are still here. And here are all the maximum times. So this is kind of your band or range that this whole process could take. And then I ran my proposed optimized method, the data-centric method, through the same thing. And as you can see, my data set here shows a slightly different variation of range, but much reduced in terms of labor hours. What does that mean? Well, if you have one document, a document-centric approach will work just fine. If you have 5 documents, maybe you might see some benefits. If you have 30 documents, you're certainly going to see some benefits. So really, now you're starting to deal with the complexity of a project and how many specifications and standards they might have to deal with, and where it could be beneficial to start using more of a data-centric approach. So that's how you interpret, or I interpret the results. But generally, the instance table gave me the data. I then used Excel to understand the data and to interpret it. I ran the same thing for the other simulations for processes 2 and 3. Again, these were the requirement tool collaboration and the minimizing and consolidating requirements. And as you can see here, we do have some overlaps, but for the most part, using a collaborative tool is very beneficial if you have a high number of change iterations where you need to go through and constantly review the data or have people in there looking at the data. With respect to consolidating your requirements, there's some benefit depending on who's getting your requirements. If your requirements go out of house to a supplier, doing the effort up front to consolidate for them so they don't have to do it will add some benefit. Generally, suppliers aren't just familiar with the requirement set, so they're just going to get a whole bunch of things and have to figure it all out themselves. It will generally be impactful if you have a lot of suppliers and a lot of products. If it's one product or a couple of products, it might not make a difference. And if you have an entirely in-house team, it might not make that big of a difference either, because they're generally on the same team and they're more familiar with the results. So that's really what we're seeing here in these processes. Now, when I did process 4, it was dealing with the timing and maturity. And when you deal with the timing and maturity, now I have to start doing some calculations. So this is where I got to play with using parametric diagrams. And these are 2 of the ones I created to show equations that's in my dissertation. The parametric diagrams are calculating some things based on the number of unknown requirements or unresolved requirements. These are called TBXs, for either TBR, to be resolved, or TBD, to be determined. And the number of requirements is usually a known thing. So if you have a high level of unresolved requirements, you have pretty unstable set of requirements. Your instability ratio is going to be pretty high. And that means you got to probably go through a lot of change iterations. So then we figured out, well, what could it cost to do that many change iterations if you know what a cost per change set is with a supplier? So that's really what's going on here. Now this diagram was the most fun. This was when I learned to integrate Excel with a activity diagram. So process 4B, which is where I use that Excel file on change cost optimization, which is how long should you wait before you levy your requirements on a supplier, was integrated in this fashion. This is an opaque action. And this is an Excel helper set of calls where you put a bunch of inputs in by set value, and you get a bunch of outputs out by get cell value, and you can assign them to parameters. And when I learned to do that, it was very valuable because it integrated the idea of calculating things at a deeper level than what you will typically see an opaque action do. The other idea I had was to use MATLAB here instead, and opaque actions in MATLAB definitely can integrate together, but I didn't need to do that. The Excel file actually did the trick. So I ended up just kind of using this, and I got exactly the results out. I input in the results using these inputs here, and I got out the results using these outputs here. And the Excel file itself is embedded into the model. I have not played with the idea of referencing it in a hyperlink. I suspect that is feasible. I just didn't take the time to investigate that. So here's the overall requirement model then. As you saw earlier on Visio, it's a series of steps, and then there's embedded steps that are kind of hard to draw in Visio. You usually have to do that on another tab or another place. Well, in the activity diagram, you see the forks. Those are actually processes within that step. So it would run through and go into the deeper level of processes and then come back out to the next step. And I'm going to simulate that for you shortly. But that's what I love about doing this in SysML is you can see that multiple dimension, multiple layers of activities that have other activities. And then for that holistic requirement management model, I built in those smaller process models, process 1, 2, 3, and 4. Here is like this example, where if you were to take an optimized path, you would go to the right here, and you would run through all the green processes and some processes that I didn't necessarily optimize, but were still part of the process. And then there's also some calculations you can do. As an example, if you're going to consolidate and minimize your requirements, you'll likely see an output of that. So I assumed a 10% improvement. Could be much more, could be a little less, but 10% seemed to be a reasonable expectation. So then I would have it reduce the requirement quantity by 10%, and I would wipe out all the difficult requirements. I've spent the time to consolidate them so they're all now traceable and necessary and sufficient and not overlapping. And then I would have it essentially walk through its different steps if we're optimized, or through the yellow steps if we're not. Oh, and I also utilized SysML in here. I think it was another step. So that Excel file where I wanted to double check how the requirement quantity mattered, I had another thing in here I didn't quite show where I used SysML in an Excel integrated fashion, just like I did with my other model. Okay, so how did I then apply things to that comprehensive model? I studied 5 different space projects. 4 have been completed, 1 is still in work. And then I looked at its parameters. I evaluated its number of requirements. Luckily, NASA makes this stuff pretty publicly available, so that's why I utilized those. And I was able to predict by turning a few knobs, such as my TBX count or my delay costs per month, or my cost per change. And I was able to, in fact, my red bar should be below here. My cost per change is another knob I turned. And I was able to kind of see how the results from my model compared to the actual results of the program in terms of how well they did. Turns out that, in case I don't have it on here, Maven actually ran really well and didn't need a lot of optimization to begin with. And you noted they had very little difficult requirements, very little overlap. They were pretty, it's a pretty well-run program without a lot of challenges for cost or schedule or technical. The others definitely had a fair share of challenges to different levels. Constellation was canceled because of their challenges. And so my results tended to trend. Maven didn't need or benefit as much because they tended to start off with a good protocol, and it was a fairly moderately sized program. And then as you got up in complexity, the need for optimization grew a lot more, and the benefits I realized in my model grew a lot more. Oh, here it is. And these are the ultimate results. So Constellation definitely would have benefited from the optimization techniques. Goes and MSL would have some benefit. Maven, maybe less so. And then HLS is one in work currently. And, you know, there's a prediction of how it could benefit. Okay, so before I go to my model, unexpected modeling lessons I just wanted to highlight for you. Things that surprised me when I started running them was that the parametric diagrams calculated results immediately as upon starting the simulation. I didn't actually know when it would do the math, and sure enough, it did the math right away. All of a sudden, my instability ratio was figured out and inputted into the activity simulation. I was also surprised to see how much math you can do with opaque actions. I always thought parametric diagrams for how you did equations. You can use opaque actions, as you saw in some of my other pictures. And you can use different languages. You could actually integrate with MATLAB and have it use a MATLAB language. You can have it Java. There's a built-in math protocol. So you could specify the language and the operation sequence in the opaque actions. Value specifications, I did use them. You'll see them. I found out later they're extraneous. In many cases, I didn't need them. And that was surprising to me too. In cases I omitted it, it's still figured out from the instance what those values were. It didn't need that call in the activity diagram. I talked about MATLAB functions. I ended up not using it, but you can integrate with that. And simulation clock is the computer clock unless told otherwise. You've got to tell it to start. So it starts its own timer from that point of reference. I also did a lot of manipulation of taking the data right into Excel before I learned how to do the instance table. So if I were to do this from start, I would have had the instance table at the beginning. I ended up finding out about it halfway through all my work and made it for all the case studies at the end, and then went back and tried it and found out I could have used it at the very beginning. So instance tables became very useful. And then the idea of that requirement, I think, is value added for the future, but I ended up not needing it. Okay, so I'm going to close out of here. And before I go to the model, I think I'm just going to take a moment and have a drink of water and ask if anyone has any questions.
Yeah, I was curious on the maturing of the requirements. How did you handle that? You had a ratio of requirement instability per month, and then how did that flow through the process? Did that get reduced over time, assuming that you're slowly refining those, or it last through the whole process?
Yes, and so I'm going to actually show you in the model. I'm going to close the simulation field out here. And I'll navigate the model quickly for you to show you that there's a ton of stuff here. But ultimately, sometimes it got very hard to manage in the containment tree. So I would just always dive to my diagram tree to find things. So in the parametric diagram, instability and change calculation is here. And so what I call the instability ratio is my TDX over my number of requirements. And so that's reflected here. That comes out to what I essentially do to control my change count. So I made an assumption of improvement per month. I had to use some starting point, but this is actually something you could vary. If you think you could improve something at a faster rate or a slower rate, you can change this, but I would have it improve by 10% each month. Is the rate I set. And so then that would calculate the number of changes I think I might need. So if I have a 60% instability ratio and I think I can do a 10% improvement each month, then I'm working through so many requirements. It might take 6 change cycles. And so if you cost $1,000 per change cycle, that's $6,000 of change cycles. So that's how this math ended up working out. This is just a starting point. I think each project would understand whether they have an experienced team or an inexperienced team, or a lot of requirements or challenging requirements, they would probably play with this a little bit in how much they think they can improve per month. Did I answer your question?
No, that was exactly what I was looking for. I think it would be interesting, just from my perspective of a real project, as you go, about 5 months in, and then you suddenly get a big dump of change, and then you got to go rework things. And it'd be interesting to compare the two approaches of your proposed versus document centric to see how it handled a big slug of changes a couple months in.
Yes, and this doesn't have to be linear, right? I made it linear because I'm just evaluating two options at a high order. Definitely, if you want to take things so it's not linear, and you think you may have a bunch at the beginning and you're front loading them and they taper off later, you certainly can play with that. Let me show a simulation and walk through some of that as well, as I think this is the part that a lot of people might find interesting. And then we'll go back and talk about some of those other parameters that were part of my assumptions. Okay, so as I described earlier, I definitely built these simulation blocks here. So I created one big master simulation thing. You obviously can't read that, but you can see how many I have in there. It's quite a lot. And again, I use the color coding for my processes here, so I can keep track of 1A and 1B, yellow and green. And then once you make a simulation config, you'll start seeing them in the dropdown. And then you can use that to execute a simulation. Here's a result table. And then what these do is grab from a folder based on my simulation configuration. So I named these folders kind of 1A, 1B, 2A, 2B, so I can find them. And so I had the simulation configurations tuck the results in the appropriate folder. And so now when I run one, it adds a new instance and then adds it to the table. So we're going to do that here. And we go on to my document focused process. Oh, I was going to show you the instance model real quick too, the instance block. So here are my instance blocks where I go through, and I'm only showing the parameters that matter for that process model. So you notice in the first process, I got dot count in here. In the second process, I've got change count, and that's, number of changes matters for that process. And for number 3, I got number of product suppliers and design teams. So I'm only showing the ones that really mattered for those processes. But I can go in here and I can change it like that. There's a couple different ways. You can open the specification up and go under slots and change it, or you can go and just highlight it and change it. And then a lot of how I ran this then is I would go in, change it, run the simulation, change it again, run the simulation. And on my table then I showed doc count. So every time I changed it, it reported it. So I just changed it to 8. So we're going to go in and choose doc-centric, and I'm going to hit run. And then what happens is you'll see this appear because I asked for the timeline chart. So I'm going to push it off to the side, and you can kind of see it running through here real time. And then you can start to see the counter here. So it's pretty fast. I could slow that down with the clock ratio, but I tended to want this to run pretty fast, so it did. I'm going to close this out real quick. And when you do use the timeline, the first thing I noticed is you had to press stop. And I will admit, I don't know why. But I'm going to run one without the timeline chart, and you'll see how it's slightly different. So the process terminated in 55 days. Well, that's not hours. Well, yes, when it reports to the screen, it'll convert everything to the days. But when it reports it to my instance table, there it is. It will give it to me in hours because I asked it to. It's the parameter assignment I made. And so what I do then is I've got yet another entry into my table. The other thing I found out is you see this little icon change. What's interesting is somehow I managed to make my model do this extra stereotype in these items. I don't know why. custom image holder. I did something somewhere along the way where it assigns the stereotypes now, but it doesn't do it for everything. So I think I just flipped a bit somewhere in one of my parameters, and honestly, it doesn't do anything with my data. It just makes it look different. So I didn't spend too much time troubleshooting it. Okay, so let me do the data focused one real quick, just to show you a slight difference in how that simulation works. So I'm going to go through my activity diagram and data focused. And there it is. And in my instance, I'm going to also make it 8. And in my instance table, I'll bring that up too. So stand by. That's the current value, by the way. It's reading the current value. So we'll have it read the new value here shortly. There it is. And now I'm going to go select data centric. Now this one does not have the timeliner on it, so you won't see it appear, but you will see this whole thing finish pretty quickly. So again, the counter here goes up every pass and then resets to 1. I didn't have to press stop, and it gave me 14 days, 55 days for the document centric, 14 days for the data centric. And you could quibble with me that you thought my values are wrong here, or you thought I do the loop counter wrong. And it's certainly worth picking that apart. You know, do you even agree with my assumptions? But for now, let's just say these are proven out by most of us who have been experienced, and I interviewed some folks. So I had some peer reviews on this. So if we feel pretty comfortable, we've got the basic process here right, and we've got the basic time durations here right. Now let's go look here. And here we go. We just ran this, and there's even a timestamp on here. For 8, the result is 340 hours. For 1, it was 200. For 2, it was 220. So not a huge difference. But once you get to 30, it's 780. So compare that here. 30 is 4,000, right? Like that graph I was showing you earlier. So essentially, this instance table can be exported nicely here. Sorry, this is read in, this is read out. And you can hit export, and you can export this to Excel, and you can manipulate the data pretty nicely. So running the individual processes and getting the various graphs was nice to talk about a specific process, but let me run through the overall process with you here, because I do want to take a moment to show you the overall study before I run out of time. So this is the requirement model. And if you were to go in here, you see you've got my expanded version. I actually already had it up. And if you were to go in here, you'd see this is all not color coded and assigned to 0. I pretty much normalized everything else. I only wanted to measure the things I was changing. So one thing I note is don't use this as an absolute measurement of time for the whole thing. I'm really only using this as a measurement for comparison purposes of current state and proposed new processes. Now I'm going to bring my table up here. This is where I'm going to report the results just for today. Do you notice this says Maven? You can actually go in here and change the names of each of these line items. I am going to run a Maven simulation for you. First, we're going to do a case study change of Maven. So here is my instance for Maven. And now let's just say it will take cost per change cycle. Let's just say it's $1 million. It's really expensive. I have enough zeros on there? I think I do. Okay. Now I'm going to run it. I've changed the one parameter. Now I'm going to flip a little bit between this tab and this tab to kind of show you a difference. But now I'm going to go into Maven, hit run. This one does have a timeline as well. I'm just going to push it off to the side. Now I'm in here. You can see where it's at. It took the optimized path. So I had in the instance table said, take the optimized path. And you could blend, maybe only want to do optimized for process 1, but not for the others. I just made mine all one or all the others. I think it's a future opportunity to investigate whether combining them adds a uniqueness to it. So I'm in here now. Now I'm back out in the main model. And it's running through, and you can see the data runs through here. The simulation time is counting. There is ways to check the simulation timer. I know one of these allows you to bring up the clock. And you see I have it report my TBX count improvement. We're off planning verification and monitoring and changing requirements now. And now we're done. So I'm going to go in here. And my value's not here yet because I have to press stop. And there it is. So if I wanted to rename this, I just need to go in here and say Maven high cost change cycle. And there it is. The duration is probably least interesting to me, perhaps, as a change count and a wait to levy and how many changes did I have. So I can vary my TBX parameter and get a different change ratio. But essentially, a lot of this data then went to feed what would my direct costs be, what would my labor costs be, and what would my co-syspo costs be. And so this doesn't show all of that. I kind of truncated it for simplicity here for us, but I grab all of that data from this model. And then I am able to kind of use that to compare the optimized versus not optimized approaches. All right, I do want to give some time for questions. So that's a highlight of my simulation. If you have questions, please go ahead and ask.
Have you looked at incorporating any different types of uncertainty in the different elements, like a normalized distribution, for example, if that's a good way to represent one part's uncertainty, rather than, I think right now it's like a uniform distribution, or because there may be, I've seen like Monte Carlo type simulations to get a better sense of the probability that the cost is above or below a threshold, not just the min max that you may expect, but more of a probabilistic assessment from using more complex distributions to model the uncertainty in different parts of your model.
No, I did investigate potentially doing that, but I found that just even looking at the basics, just looking at it linearly, I found such a range between the proposed and the current state that I didn't feel the fidelity of doing more probabilistic look was actually warranted. The first order approximations gave me a huge variation. Now, why did I choose those 4 processes? Because we actually see in action a lot of the benefits from one versus the other. So I chose ones that we actually see in practice work better, and I just wanted to model them better. But I think it would be really wise if you were really looking at investigating using some of these and you don't see a clear-cut difference between the two, to do more of a Monte Carlo. Surely there are other questions out there.
I mean, I have another more general question about, you mentioned, we want to make sure that these tools are accessible to, not just the system engineers. Do you have any recommendations, or maybe how you, how did you try to do something to make this more accessible to, say, other people you're working with who maybe weren't as familiar with the tool? Or
yeah,
what
and
are
it
your
wasn't this tool, by the way. When I was comparing requirement management tools, so the Cameo System Modeler is actually one of the tools that some people use for requirement management.
Sure.
I think they look a lot like these kind of tables. The tools I was speaking of are things like IBM Doors, IBM Doors Next, JAMA Connect. I did a whole investigation of different tools that are out there, and what I have found is there are a lot of new modern tools that are great. There are a lot of tools that have been around for years that people are just using because they've always used them that aren't great. And trends are, if you have a tool that's hard to use, Cradle and Doors come to mind. You'll find a poor system engineer assigned to always be the gatekeeper on that tool, and that's their job forever. And that actually limits their career, which is sad. But also, people don't want to interface with the tool. And what we've learned with tools like JAMA and Doors Next is you'll have anyone in the tool. It's so web friendly. You just log in, it's like a web browser, and they see anything, and it's very intuitive, and they can find their requirements, and they can find trace to verification. So when you have that, you find more people in the tool understanding the data that's in there and the relationships of the data, which is huge. Cameo is an awful requirements management tool. And I say that because it's not user friendly from somebody who's just trying to look at connections of data between requirements and verification. You can see it, but it takes a lot of training to learn to use it. It's not as intuitive right out of the box for a lot of people. And we're finding that with our MBSE practices too. People get a little intimidated with these SysML tools, and it takes a lot to learn to use them.
I guess building on the previous question about making the actual system modeling tool more accessible to other users, do you think the Excel interface that you used, even if you were really just using this for pure system modeling of a product design or something, that would be a way to bridge the gap? Maybe you have electrical engineers entering cost or weight into Excel, and then that can be brought into the system model so they don't have to learn the tool?
Yeah, what we're learning in a lot of digital engineering ideas now is subject matter experts are comfortable using the tools that speak to their domain. So electrical modeling tools, mass modeling tools, thermal tools, the subject matter experts want to work in those domain tools, but bridging those tools to the system model is powerful. And so a lot of companies are now looking at how to integrate all this data together so they're not siloed and potentially got errors because they are siloed. Well, anyway, I have a lot of fun doing this. I will say I'm going to make this model available. This has been a lot of fun. There's a lot of things I would be able to expand upon, but the one lesson I learned in modeling is set the scope of your model and don't overachieve, don't overmodel. And because you can take this to many places. I could add a lot more parameters, a lot more tables, a lot more stuff, but really I was modeling to solve a problem. And once I received some data around that problem, enough for me to analyze and understand it, I stopped modeling because I didn't need to, and I had other things to do. So in a professional environment, what that means is when you set up your team to model, understand the problem you're solving and solve that problem. And you may question whether or not you want to expand that model to other things, but only if there is a need. Don't model just because it's cool. So that's my ultimate takeaway. We use that at my company a lot is be very mindful that you understand what you're trying to solve. Doesn't appear like we have another question.
I have another question on the simulation side. So when you were creating the simulations, were you running a piece of it at a time and making sure it worked? Did you have kind of a development workflow that you could share? Were you using the breakpoint feature, for example, to pause it and make sure that things were working? I guess I'm curious, with my experience of building simulations here, with a graphical programming interface, is a little different than the other software paradigms for developing the simulations. I'm curious if you have any thoughts on how to develop the simulation in a way that, I don't want to create a diagram and then it press run and nothing works. That's typically not the best approach. I feel is to wait until the end to press the run button.
Yes, I agree completely. I did have the breakpoint feature used quite a lot. I also really valued the values that came down here. And so when I wasn't getting my counter increasing, when numbers weren't matching what I was expecting them to, I would have to, or when it would just seem to dead end, I would have to build in the breakpoint like any troubleshooting and look at what the numbers are telling me, go backtrack and find out, why is my math not working? You know, each of these equations, maybe I had an error in equation, right? I had to go back and figure out what was it calculating. There was definitely a lot of struggle to get it to give me results for the initial time as I built it, and I couldn't get it to run through. And I built it again, and it still wasn't quite giving me what I wanted. And it took a lot of trial and error. But once I got this model to work, the others quickly came in line. And I will tell you, the Excel integration was probably my most exciting moment. This was my first Excel integration here, where it looks real simple, and I'll expand it for you. But getting this data to come out, to grab that data there, which this is a screenshot, but it reminds me of what I'm grabbing, to get these inputs in to match the output I needed, took a ton of time. And then I realized what was going on was my assignments and my opaque actions weren't going in the right block. So body and language, not name. That took forever to figure out. And then I eventually had another parameter related to the value specification and how I was assigning those. So, and this is where I got a lot of help from experts, but I will tell you that one, once I got that to work and actually get data in to give me the right data out, my other Excel integration went really smoothly for the second file.
Okay, great. Well, thanks, Tami, for giving this talk and showing us your model. And yeah, it's very exciting work to see, and I'm glad it sounds like you're willing to share some of this. And it might be great to review if you're making your own simulations and see how she actually got at the work in some of these cases. So thanks again. Thanks everyone who was able to attend. Yeah.
Thank you for having me. I really appreciate sharing this with you. I'll take off. Take care.
Yep. Thanks. Bye.